Right. Stop the ThreadLocal and button. Expects some type. Let's look at documentation. Oh, ThreadLocal random. So, ThreadLocal. Blank. Right. Sorry, my OBS stopped working. Okay, now it works. Had to refresh. Local. Let's read something about it. This class provides ThreadLocal variables. These variables differ from their normal counterparts in that each thread that accesses one via its getTokenSet method has its own independently initialized copy of the variable. ThreadLocal instances are typically private static fields in classes that wish to associate state with a thread, example, user ID, transaction ID. For example, the class below generated unique identifiers local to each thread. Thread's ID is assigned the first time it invokes and remains unchanged on subsequent calls. Okay, we have atomic integer class thread ID, atomic integer containing the next thread ID to be assigned. Okay, it contains thread ID. ThreadLocal variable containing each thread's ID. So we have ThreadLocal of integer, thread ID, ThreadLocal new thread local, and we overwrite. So well, let's copy it and paste into code because it's hard to read actually. Oh, it copies with this readable. Okay, let's put it in our code. Done integer. Yes, I understand it. In each thread local contains its its own ID, which which is unique. And we can get this ID from local using get method. Alright. Each thread holds an implicit reference to its copy of a thread local variable as long as the thread is alive, and the thread local instance is accessible after a thread goes away. All of its copies of thread local instances are subject to garbage collection unless other references to these copies exist. Local line prop thread trailer prop has maps attached to each thread. Okay, we can use with initial, right? So we can ask existing thread whether it has thread local. What is get map? Okay. Yeah, we have this variable, then we can set a value, then we can get the value. Yeah, we can use with initial. Okay, we can also put, instead of integer, we can put an object, obviously. Okay, we create a class which implements runnable. We also have this variable, which is concurrent hash map. What it does, it retrieves some data from repository by this user ID, which is undefined, which is null, null for null, right? Where then we can put this key value to this concurrent hash map. And then get is this is in constructor or what? User ID, we pass ID, which becomes user ID, right? Okay. Oh, it's the first approach. We can store user data in map, or we can use local. We can write our example to store context instead using local. Yeah, here we have just context variable which is static. Same thing, we set the context. Prints username, but I don't see if it prints context. As I know, they are different, even though they are static. Right. But we have to check it because they don't print this object. Let's copy it. we also need context. User repository, we don't need this. Just say username like we need constructor. I believe it's better to use final word because it requires final. It requires us to provide this value, the constructor. It's content for input this function. Okay. User context close. Let's say 1 and 2. Local 1, local 2. Actually, they are runnable. It doesn't. When closing instance of type app is accessible, must qualify the allocation and closing instance of type app. X new app. X is an instance of app. So it complains about static word. I get it. We can, what we can do? We can just say static. or yeah, it will help, but I think we better use another class. Static here. No, like so. No, it doesn't complain. Okay. Now we can put it in the chat. In the chat. Yeah, just say start. And we send it wait. It's about exception. Thread exception. Okay. Again, it says that we have different classes in your context. And I wanted to check what, sorry, they have different context. Oh no, we have different user context. Yeah, even though they are static, they are different. No, user context.get returns the context itself. So we can say like dot like, let's go to the context and dictionary getter. We can mhm. You can say get name. Yeah, we have different time. That means contexts are different, but we know nothing about user context variable. Let's see what it says. User context. They say that says that it's the same object. So I was wrong. Uh, it's static, so yeah, it's static. Means it's the same object. It references to the same object, but contains different context. I don't get it. Say it's not static. It builds. If we run it, it still says it's the same object. It's kind of yeah, it says the same object. Oh, we have it. Yeah, we have the right. Sorry. Yeah, now it says different object, which is logical. And why do we need ThreadLocal to be static? So Okay, it's like a variable which lives inside the thread. We just could use like private context and set this context to this variable if it was like private field. The only difference is it would be mutable, but we can mutate it also using set method. I don't see the difference. Like we could say I mean we could do this like private not private yeah private context say now and then we say just these dots text equals okay, new context username right. Then we could print instead of this we could is not text. It would do the same thing. Context dot yeah, it would do the same thing. The difference is that we can access the context anywhere in the inside our methods, like public with print context ThreadLocal, right? And we don't pass anything there. We just can say no this, no all this. How to get thread local from anywhere. Okay, let's read this. Let's go like thread local Java get thread local. Thread local dot get. Okay. So we can say thread local dot get right? No. I love it. She said it's not static. She get returns value the current thread's copy of this local variable if the variable has no value for current thread. First initialized to the value returned by the invocation of initial. Mhm. Still don't get it. Like we say, we can say like user context dot get. No, yeah, this is private method. Let's read more about ThreadLocal. That can only be written by the same thread, thus even if two threads are executing the same code, and the code has a reference to the same ThreadLocal variable, the two threads cannot see each other's ThreadLocal variables. Thus, the Java ThreadLocal class provides a simple way to make code thread safe that would not otherwise be so. Create ThreadLocal, set a value, then they can get this value. They don't use static. They also can remove value. Okay, I get it. You can use generic type. Okay. Okay. Yeah. Play the string of thread local. Okay, they created a class. They created a local variable. Yeah, here for local example. My runnable, what is my runnable? Here is my runnable. It has ThreadLocal without static word. Yeah, they start, they join. Okay, they set the random value. This example creates a single myRunnable instance which is passed to two different threads. Yeah, it's the same. It's the same object instance. Same instance. Both threads execute the run method and thus sets different values on the thread local instance. Yes. If the access to the set call had been synchronized and it had not been a thread local object, the second thread would have overwritten the value set by the first thread. However, since it's thread local object, yeah, and the problem here, yeah, they created two different objects. Is it the wrong example? It's just misleading. Right? Yeah, we can let's check it out. Okay, we created we have to create only one object here. Delete this. We don't need this. Okay, this. Then we create new threads, which call the same, which where we pass the same object. And here is the problem. Yeah, and we can just print it. So this, let's see. Yeah. As you see, we have the same time, the same. So our context is the same in two different threads. Okay. And if we use ThreadLocal without, let's try without static first. Yeah, we see different time on the same object, on the same user context. And it doesn't matter if we say it's static, right? If we say static, oh, it doesn't matter if we stay static or it's or not static, which makes sense. Yeah, the same variable and two different values. Okay, this example on this website is absolutely misleading. It, it just it's just wrong. We shouldn't create uh, different runnable. We should use the same runnable, and that's just the very bad example. Very bad. We don't need this just useless information like this user repository, get username for user ID. It doesn't explain the main idea, and the main idea is completely lost. And here we have right explanation. I don't know why it it's the first link when I googled ThreadLocal, and it's the bad link, bad explanation. Sorry, I don't show you the screen. Yeah, I mean this page is they completely lost the main idea. Like we use the same object. They use two different objects. That's why uh, that's why I was confused. Like we can create two different fields, and this explanation is great. Okay, so what's next? Yeah, we can create. I got the idea. We can create something like multi. We can keep user credentials here. Like we create one object to create one runnable which contains ThreadLocal. Then we create many threads, and at the beginning of for run method, we can retrieve some user information and contain it and keep it here inside ThreadLocal. And the problem is, like in this method, we should have reference to user context. I thought like we can access it statically. Yeah, but that's no, it's not possible. Yeah, anytime we call .get, we get different context, different user credentials or whatever we keep here. And it doesn't matter if we say it's static or not. In both cases, it will be the same object. Interesting. I think that's enough, ThreadLocal. Yeah, that's hard to find where we can apply this, except for user credentials or something like that. Okay, I'm gonna end this stream for now. We'll see what's gonna do next.